at SOHCAHTOA. Okay, look at our SOHCAHTOA. And I want you to look at our CHO-SHA-COW. Okay, and I don't know if that'll stick or not, but I saw another teacher used it, so I'm like, well, we're going to give it a whirl. What do you notice about from SOHCAHTOA to the new ones? There's a connection in partners here. Okay, and I like how you're describing that. Do you see that sine theta, and you always need an angle, okay? Because it has to be the opposite of an angle. You can't just do, and every year I have a student who does this, they write sin equals 4 over 5. I'm like, that makes no sense because you have no angle you're coming from the opposite of. Like you can't have sin equals 4 over 5. There's no angle.
Wait, so then would you say if there is an angle, would you say, and it's like angle C, would you say like sine angle C?
Yes, you would write sine C, sine K. Yeah, you put the angle in there. Okay. And so here's what big idea. Sine theta is opposite over hypotenuse. Cosecant theta is what we call the reciprocal of sine because you flip the fraction. Hypotenuse over opposite. Cosine theta is adjacent over hypotenuse. Secant theta is its reciprocal. It's hypotenuse over adjacent. Tangent theta is opposite over adjacent. Cotangent is adjacent over opposite. Now, tangent and cotangent sort of make sense, right? Because they sound similar. The bummer is whoever named these hundreds of years ago, wish they would have done it differently. Sine theta in its reciprocal starts with a C. Cosine theta, its reciprocal starts with an S. So I just remember they switch. Not mathematical by any stretch of the imagination, but that's it. Okay, so we're going to organize them all together now in the box. So here's what I want you to do. We're going to draw a right triangle. We're going to put the angle theta. Then there's your opposite, adjacent, and hypotenuse. And here we go. I'm going to put sine theta is opposite over hypotenuse, and underneath it put cosecant theta is hypotenuse over opposite. So these are called reciprocal pairs. Cosine theta is adjacent over hypotenuse, so secant theta is hypotenuse over adjacent. Then my third pair is tangent theta is opposite over adjacent, so cotangent theta is adjacent over opposite. So I don't know if the CHO-SHA-COW will work. If it works for some of you, great. If it doesn't work for you, great. It doesn't matter. However you're going to remember them. So the three new ones, and they're pronounced cosecant theta, secant theta, cotangent theta. All right, so now you will be asked oftentimes to find 6 trig functions. I'm coming from angle R. So here's how you're going to write this. You're going to write sine, and it's capital R is the angle. So what is the opposite over the hypotenuse for sine R? Good job. It's 4 over 5. Now what I do is I immediately write the reciprocal underneath it because all I'm going to do is flip my fraction. So cosecant R is 5 over 4. Does that make sense? How they go together. Then cosine R is adjacent over hypotenuse. So Lily, what would be adjacent to R over the hypotenuse? Good job, 3 over 5. Then I want its reciprocal. So Mia, what would secant R be? 5/3. So the reciprocal, you're just flipping the fraction. All right, now tangent R is from TOA. So William, what's tangent R?
4/3.
Good job, 4/3. And then Emma, what would cotangent R be? 3/4. Okay, so I'm going to pause a moment, and I want you to do example 3. I want you to find all 6 trig functions of angle K. You need to have an angle inside the trig functions. If it helps, I didn't do this on example 2. You do what's best for you. If it helps, label what's the opposite, what's the adjacent, and what's the hypotenuse from angle K. Okay, whatever you need. All right, Jake, what do you get for sine K? 12/13. All right, Liam, then what is cosecant K? 13/12. All right, Elise, what's cosine K? 5/13. And then Gabe, what would secant K be? 13/5. Then we're going to do TOA. Tangent K. Mackenzie, what's tangent K? 12/5. Then Cal, what would cotangent K be? 5/12. All right, these 2 triangles are examples of what you learned, Pythagorean triples. So a 3, 4, 5, a 5, 12, 13. These are very, very common from a squared plus b squared equals c squared that are integer values. So in example 4, I'm going to now take you up a level. You did this in geometry. What if I am missing one of my 3 sides?
It's a 30/60/90. So.
There's no indication of a 30/60. Good try, though. Sarah, what'd you say? I think I heard you.
Do you find angle using one of the trig, like sine or cosine?
I'm not actually trying to find theta. No, I'm not trying to find theta. Jake? Yeah, you want to use a squared plus b squared equals c squared. Now, Sarah, you're ahead of us. Like you had good thinking there. We eventually can do that to find theta, but this is all I want to do is write the 6 trig function ratios of angle theta. So here's what you're going to do. You're going to do 8 squared plus 15 squared equals c squared. So grab a calculator if you need it. So I get 64 plus 225. That's 289. So I would do the square root. Anybody got it? Avery? 17. You got it. So then I'm going to label that. If it helps, label your sides. All right, so here we go. And I need to speed up a little bit so I can get this done. So that's going to be 8/17, 17/8. Cosine theta is 15 over 17. Secant theta is 17 over 15. Tangent theta is 8 over 15. Cotangent theta is 15 over 8. Remember to reduce all fractions if possible. What I mean by that is if I had 5 over 15, I would make that 1/3, okay? All right, in the next one, I don't know, I can call that side A, and we would do a squared plus 2 squared equals 5 squared. 25 minus 4 would be what? 21. So A is the square root of 21. So label your opposite, your adjacent, your hypotenuse if you need to. If you're comfortable doing opposite adjacent, terrific. You don't need to label them. But if it helps you, then please do so. All right, so watch what's going to happen. I'm going to do sine theta is 2/5. Cosecant theta is 5/2. Cosine theta is square root 21 over 5. And secant theta is 5 over the square root of 21. We have a problem here in that reciprocal, secant theta, I can't leave a square root in the denominator. So watch what we're going to do. We're going to rationalize it and get 5 square root 21 over 21. So be careful. Be careful when you land with a square root. So this is 2 square root 21 over 21. Cotangent theta, though, is square root 21 over 2. All right, now I'm going to get to what Sarah was talking about. We can actually use trigonometry to find missing sides and angles. So in example 5, it says find x. So here's what I'm going to do. This is the opposite, this one's the adjacent, and this one's the hypotenuse. So what I do is 20 is the adjacent. The one I'm looking for is the hypotenuse. So out of SOHCAHTOA, which one would contain the adjacent and the hypotenuse? Cosine. So watch what you're going to write down. Cosine 43 degrees equals 20 over x. Grab your calculators if you don't have them out, because we're going to need them. And your mode should be in degrees. You have a mode on your calculator. On the TI-84s, there's literally, on the TI-84s, beside the second button is a button called mode. Press it and toggle it from radians to degrees. If you have a TI Inspire, you go to the on button, is the home button, and scroll down to where it says settings. And then it's something like document settings.
Add geometry? Is that what it is?
No, not geometry.
Calculation mode.
Go down to settings, number 5. And then it says document settings. And then yours is already in degrees. Perfect. Go down to angle. When it says angle, if it says radians, put it in degrees, but then say okay or make default. You might have to say make default. All right, so watch what we're going to do. Make this a proportion. You're going to cross multiply. Then you divide by the cosine 43 degrees. So we're going to figure out round 1 decimal unless it says otherwise. Round 1 decimal unless it says otherwise. If you're not getting 27.3, raise your hand and let me come help you individually on your calculators. All right, so now this one, do you notice that this is a 45-45 right triangle? I should not use a calculator. Okay, anytime you see 45-45 and 30-60s, you should not touch calculators. So what is X? Just looking at this based on what we learned the day before. 13. And then what's Y? 13 radical 2. Okay, awesome. But watch this, okay? Watch this, okay? If I said to you, I have the opposite and the adjacent, do you see tangent 45 is X over 13? I can cross multiply. Check it on your calculator. Do you get 13? You sure do. All right, so across from the 60, let's go ahead and just practice the SOHCAHTOA. This is tangent 30 is X over 4. Make it a proportion and cross multiply. So I'm getting X is 2.3. Then to get the Y value, that would be cosine. Well, I'm going to do cosine 30 is 4 over Y. So Y is 4 divided by cosine 30. Do you see I could have done sine 60? I could have done sine 60 is 4 over Y. I'll still get the same answer. Oh, look at that. Isn't it double? 4.6. That should make sense. So in a 45, 45, 90, the legs are equal. In a 30, 60, 90, the hypotenuse is double the short leg, which we learned yesterday. Is this coming back to you from geometry? Okay, so I am going rather quickly because besides cosecant, secant, cotangent, this is all review from geometry, just trying to get the cobwebs out from a year ago. All right, in example 7, it says, using trigonometry, find angle theta, and then find the third angle in the triangle. So from theta, this is the adjacent, and this 2 square root 3 is the hypotenuse. So what trig function from sine, cosine, tangent, SOHCAHTOA would I use? Cosine. So you're going to write cosine theta equals 6 over 2 square root 13. Who can tell us from geometry, how do you undo the cosine function? It's not sine. Maybe take a look at your calculator buttons. Okay, well, that's called, you're going to do the inverse, and let me show you this. You're actually taking the inverse cosine to both sides because inverses cancel each other. And then all you do is on your graphing calculators where you see your cosine, like on the TI-84s, you hit second and cosine, and that'll pull up the inverse. And I'm getting 33.7 degrees. Round 1 decimal unless otherwise asked. So if theta is 33.7 degrees, what's the other angle? How would you figure it out? Okay, both are correct. You could add the 2, subtract from 180, or DP's doing a shortcut. If you know you have a right angle, the other two have to add up to 90. So you could take 90 minus 33.7 to get 56.3. Either way works, okay? Either way works. So, when you're trying to find an angle, you have to undo the trig function, and that's where you're using the cosine to the -1 or sine. It's called inverse cosine, inverse sine. That's the only time you're using that button, is when you're trying to undo the angle. All right, so there are two special right triangles, and we looked at these yesterday. And if you look now with SOHCAHTOA, do you see sine 30 is 1 over 2? Sine 45 is 1 over square root 2 that rationalizes. And sine of 60 is radical 3 over 2. So, looking at that chart above, here's what I want you to look at for example 8. Do you see that I would do the cosine of theta is 4 over 8? Well, that reduces to 1/2. What we're going to work on in the rest of the unit is something referred to as the unit circle. And the unit circle is foundationally based on the two special right triangles. So if you look at the chart above, what angle, when I do cosine of it, gives us 1/2? If you look at the chart. 60 degrees, right? It's 60 degrees. So you'd have to reduce the ratio, and then what's going to happen is, and this is okay if this is a little confusing right now, because we're going to really develop it, but we're looking at these right triangles. You're going to be writing them down over and over and over again until you start to remember them. So if we look at this one, if I said I have opposite and hypotenuse, so this is the sine of 30 is 10.8 over x. And it says figure this out without a calculator. And you might be saying, how on earth am I supposed to know that? Well, here's the deal. Let's draw the 30-60 right triangle. And we developed the numbers yesterday. Remember, I drew the equilateral triangle with 2, 2, 2, and we developed. So you're going to have to memorize or remember these or redevelop them. So what is the sine of 30 based on the special triangle? It's 1/2. So if sine 30 is 1/2, what is x then? 21.6. You would just double it, right? So you're going to be able to do problems without touching a calculator. So I'm just planting some seeds, okay? Planting some seeds right now. All right, in example 10, it says draw a right triangle that would show the sine of 40 degrees equals x over 8. So let me pause a moment, and I want to see that you can draw the triangle.
Just McInerney.
Yeah.
My calculator's like not.
Okay, let's take a look. Whoa. Okay, were you doing this button?
Yeah.
Let's go back up to that particular problem. Oh, you know what? Okay, I see what happened. So 6 divided by, you have to put the 2 square root 13 in a parenthesis, because the way that you typed it, order of operations, it divided first and then multiplied, and then that's too big of a number. So there you go.
Okay, thank you.
You're welcome. All right, so let me go ahead and draw this, and it doesn't matter what direction you do this, but do you see that the 40 degrees is here? And you could have put it up in the top, that's okay. Then across, if this is opposite over hypotenuse, the hypotenuse is 8, and then across from it is x. So can you draw the picture based on the equation? All right, this one's going to be a calculator problem. Make it a proportion and then cross multiply. Then you're never going to make a mistake whether you're multiplying or dividing. Okay, always make them a proportion. So use your calculators, and I got, and you could say 5.1 or 5.14. All right, give me thumbs up, out, or down. How are we doing from remembering this from geometry? Up, out, or down? Okay, so we're like all over the place right now. So let's try and get this clarified a little better. So, do you remember from geometry something called the angle of elevation and angle of depression? So I'm going to redefine it for you. So if you have a horizontal line, and it's always from a horizontal line, not a vertical, okay? From a horizontal line, if you look up, looking up is called an angle of elevation. So if I look out my window, okay, so I'm looking straight across, but if I look to the top of the tree that's outside our window, that's an angle of elevation. If I'm a little bit closer and I'm looking down at the cars, looking from the horizontal down, that's called an angle of depression. And I think you understand that, but for some reason, when students do an angle of depression, they do it to the vertical. And I'm like, that's not what we're saying. So here we go. In example 11, it says Brian's kite is flying above a field at the end of a 65-meter string. If the angle of elevation to the kite measures 70 degrees and Brian is holding the kite 1.2 meters off the ground, how high above the ground is the kite flying? So let's make our person. We're going to make a kite. All right, so now this distance, now here's the ground, okay? There's a little distance from where he's holding it up. He's 1.2 meters off the ground. The kite is flying, the string is 65 meters, and do you understand that the angle of elevation right there is 70? I want to know how high above the ground is the kite. So the first thing I have to do is I need to find x, which is from his line of sight up to the kite, and then we're going to add 1.2 to that. So what trig function would you need to use to first find the x? Sine. So you would say the sine of 70 equals x over 65. Make it a proportion and cross multiply. So I said 61.1, but you have to take 61.1 plus 1.2, that's how high the kite is above the ground. Does that make sense when you see it? Okay. All right, let's do our last example. An airplane pilot sights a life raft at a 26-degree angle of depression. Okay, so I am terrible drawing, so here's my plane, okay? This is going to be my plane. Remember, an angle of depression is from the horizontal line looking down. So the angle of depression is up here. It is not the vertical. For some reason, students want to do it to the vertical with angle of depressions. And I'm like, that's not the definition of an angle of depression. Am I being clear? Am I being clear enough? From a horizontal line looking down, that's the 26. It is not ever to the vertical. Okay, it's not ever to the vertical. Now, the airplane's altitude is 3 kilometers. You're supposed to remember from geometry, what does altitude mean? It has a special meaning. Say it again. I'm hearing a little something, but I couldn't hear it. It's what kind of height? It's perpendicular, right? So, you're supposed to remember, and I'm just refreshing your memory, anytime you see the word altitude, that's a perpendicular height. Do you remember the perpendicular symbol? So, the airplane's altitude is 3 kilometers. What is the airplane's horizontal, and so here's my raft. The horizontal, so you need to understand what horizontal and vertical mean. So then I'm looking for this. All right, well, do you see that I have, and I'm going to use some geometry here, I have 2 parallel lines cut by a transversal. You remember alternate interior angles are congruent. So we're using some geometry here. So this angle down here is 26, not up in that corner, up to the vertical. So I can use 2 parallel lines cut by a transversal. Alternate interior angles are congruent. So what trig function would I use to help me find D? Tangent. Nice work. So tangent 26 is 3 over D. Make it a proportion and cross multiply. So I'm going to get D times tangent 26 equals 3. Divide by tangent 26.